All right, so we've covered quite a bit this week, but we're going to do one more because it ended up being way easier than I thought to do this. So we talked about, yes, we can control an LED based on voltage using the potentiometer, but then we started making it to where the potentiometer, we read in the value, and that we use that to do the duty cycle on how quickly an LED flashes, and that's how we can make it dimmable. Okay, the other thing we can do with PWM is we can control things like a servo. This is a servo. It's kind of sort of like a motor, except it has a very limited range in movement. And this one goes between 0 and 180 degrees. So this wing part here this is about 0, and it'll rotate, as you can see here, um, 90 degrees that way and 90 degrees back the other way, mostly. I don't think this is all that great of a servo. So, all right, the way that this works is, again, with PWM, and we're also going to use a library from Adafruit for their CircuitPython. By the way, I haven't mentioned this yet, but the CircuitPython Essentials lessons are on the Adafruit website are really, really good for seeing how to use some of these controls. They've got information on PWM and controlling an LED. So you can have this code that'll cycle it up and down in brightness. But it also has some information on servos. And one of the things about servos is we could control it strictly using PWM IO, but they have a library that makes this a whole lot easier. So to get the library, you'll open up the link to this CircuitPython libraries folder, and you'll scroll down till it says bundle for version 9.x, because that's the version of CircuitPython we're using. You'll download this zip file, and when you open it, you'll get a whole bunch of libraries that help it make it easier to do lots of different things. One of those things is the motor. So then if you take the Adafruit motor folder, and if you have the D drive here, or the CircuitPy folder, depending on how your computer mounts it, there's a lib folder in there, and you'll just copy that Adafruit motor folder. You can see here, that's where I have that. You just copy it into Adafruit, or into the lib folder, and you'll be able to reference it. Now, one of the things that I noticed, if we look at the code here, is we're saying here, from the Adafruit motor library import servo. Visual Studio Code is throwing an error about this because it doesn't know about the Adafruit motor. I'll try to look and see if we can add this lib folder to the scan folders that this is looking in. And hopefully we can get that cleared up. But it still works. It just thinks that there's an error because it doesn't know about this lib folder. But once that's done, we still have our potentiometer pin, and I left the code in here for the LED to flash, so we could just make sure that we're getting the PWM value from the potentiometer. And now we set up a new one, a new pin. This is, again, another PWM out. It's looking at board GPIO 15. If we look at our schematic page, it would be really nice if I could manually focus this. But GPIO 15 is this bottom one right down here. So that is hooked in here. Let's play with this guy. That's this last pin right here. So this orange wire. All right, the way that you wire up a servo is also really important. It has 3 wires. We've got yellow, red, and brown. Brown is going to be your ground, kind of rhymes-ish. So brown is ground. So that's just going to use your normal ground rail if you have one set up. Or the ground pin is the 3rd pin on the right here. For the red one, that's going to be your power. And so the red line we have hooked into not our normal power line. Normally the power that we grab is the 5th pin down, and that's the 3.3 volt power. But we need 5 volts for this motor, or for this servo. And so we're going to use, where do you go? We're going to use this V-bus. The V-bus is 5 volts. It's the direct line of the 5 volts coming out of the USB port, and it just comes right out of this first pin. One thing to know is that this servo is fairly small and dinky. You can run this off of the board itself, but if you get more than maybe 2 of these, you'll fry this pin. So servos use a lot more voltage, or a lot more amps, than what this pin can handle. And so for normal use cases, you're going to want a separate power supply coming off of a battery or some power supply to run your servos. You don't want to run them from the board pin itself. So then your servo and you're going to run your red wire off of your power coming from your battery, let's say. It's got the black pin, or the brown pin is going to go to ground. And then your yellow line is your yellow or orange. I'm colorblind. You pick one. And that's going to go to your pin. So we have that going to GPIO 15, which is this last pin here. So that's how we control it, is with this pin here. But just remember, you don't want to run too many of these off of your 5 volts coming out of your Pico, or you can fry it. But one for this kit is just fine. So once we have that set up, we have our pin, GPIO 15. We're going to set our cycle to 2 to the 15th. That's how you do powers in Python. So 2 to the 15th power, which is the 65,535 number. So that's why that it's just an easier way to use that number there. And then our frequency is 50, so cycles per second. And then we need to set up another variable using this servo library in the Adafruit motor folder. And we're going to say servo.S servo, and we're going to pass it our pin. So now this library allows us to just set the angle. And the library figures out all of the calls to the PWM library that it needs to call. So we have our pin val coming in from our potentiometer. We're going to shift that value using our kind of really basic line shifting equation, the value divided by 2 to the 15th, and then times 180. So that's going to be the angle from 0 to 180. And we're going to set the duty cycle for our LED, just so we can kind of make sure that's all working right. And I do print the angle just to make it a little bit easier on myself. And then we've got the myservo.angle. That's all we have to do. Set this angle to our calculated angle value, and we should be good to go. So now, if I spin the potentiometer, it spins the servo to the angle that we specify on the potentiometer. So it's that easy. It's just a few lines of code, and now we can control a potentiometer, or a servo. A great kind of use case for this is if you need to kind of open and close something, or a lot of times servos will be used for you'll hook a wire into one of these holes, and then that wire can connect to the flaps on an airplane. And so this is what you would use to control the flaps and rudders and tail fin and stuff on a remote control airplane, because it doesn't really spin over and over again like a motor does. It just spins between certain angles, and you set it to the values that make sense. So that's where servos can be really helpful. They also, I think they do draw a lot less power than a motor does. Motors are made to spin and spin, whereas servos just go to a certain angle and then stop. So that's how you control a servo. It's really, again, setting up a PWM out object for our pin, and then using this servo library, we just create a new instance and then set the angle to whatever we want. And it spins. So now we have a potentiometer that makes an LED flash at a certain rate, but then also affects the servo. So we're getting more and more little components under our belt that we can use to do bigger and better projects. And I thought with as little code as this was, it'd be a good idea to throw it in there for this week. All right.